Okay, so welcome back to my YouTube tutorials. Today I'm going to take you through this set of questions. Okay, so this is integral of vector value functions, and as the question says, find r of t given that r prime of t equal to cos t, sin t, and then t, such that r of 0 equal to I. Okay, so here we have solution. We have solution here. So now we have to rewrite the question, which is r prime of t equal to cos t, comma sin t, comma t. Okay, our main goal here is to what? Get r of t. Okay, and this is what? In its first derivative. So to do away this derivative, we have to take the antiderivative of that. In other words, we find the integral of this. Okay, so by doing that, we are going to introduce the indefinite integral on both sides. So we have indefinite integral of r prime of t with respect to what? T. Okay, equal to integral of cos t, comma sin t, comma t dt. So here I want to make it clear to you. I know you've been taught from your pre-calculus that whenever you take an indefinite integral of a function, let's say r of t dt, you must always add a constant to it, so plus c at the end. So here we are going by that. We have indefinite integral of r prime of t dt equal to integral of cos t sin t t dt. I just repeat the question again. So if you find the integral of this, you are going to have r of t equal to the right hand side, which is, when you find the integral of cos, will give us what? Sine. So we have sin t, and then integral of sine will give us negative cos. So we have negative cos t. Then when you integrate this, okay, we'll have t squared divided by the exponent again, which is 2. Okay, plus the constant coefficient. Okay, so this is the what? Integral of this particular question here. So this is the answer to that. But don't forget, the question is asking us to evaluate r of 0 equal to I. So r of 0 is equal to I. And you are being reminded that we are dealing with what? Vector value function. So this simply means it's a vector. So it means that if you are doing that, our I, j, and then k, okay, we have component of this. It simply means the I component is 1, and then the j and the k component are what? 0, 0. So here our I is simply equal to 1, 0, 0. So by doing substituting, we are going to substitute this into this function. So we have r of 0 equal to sin 0, comma, minus cos 0, comma, and then 0 squared over 2, okay, plus the constant, which is c. So here sin 0 will give us 0. So r of 0 is equal to 0, and then cos 0 will give us 1. But then the cos here is negative. So if it is negative, it simply means that we'll have negative 1, and then this one to give us 0, plus the constant c. Okay, so now you recall that r of 0 is equal to I. So we just need to come and then replace the I component there, which is 1, 0, 0. So we have here 1, 0, 0, that we equate it to the right hand side, 0, negative 1, 0 plus c. So here our focus here is to make this constant the subject, meaning we are going to find what this C is. So simply we just need to transpose everything here to the left hand side. That will be 1, 0, 0, minus 0, negative 1, 0 equal to C. So if you use this negative to open the parentheses, we are going to have 0. 0 plus 1 is still 0 minus 1 is still 1, and then 0 minus 1 will give us positive 1. Then this one will maintain it. It's still 0 equal to C. So it means that the C component here is not 0, but rather 1, 1, and then 0. So this is in the form of what? Vector function, which is represented as I, J, and K. So this is the I component, the J component, and then the K component here. So here we have to come back and then substitute it back from the question. After finding the what? Antiderivative, we have C here, so you have to go back and substitute it there. So here we have R of t equal to sine t minus cos t, t squared over 2 plus the C component, which is this. Okay, so we add it to it, 1, 1, 0. So this is the final answer, or you can rewrite it in this form: R of t equal to, okay, you group the component together. This is the I component in this perspective. We have another I component, so we add them together. We have sine t plus 1 as 1, then minus cos t will also be added to this. We have minus cos t plus 1. Then this one too, we add a 0 to it, and whenever you add a 0 to a value, we still get the same value. So this will be t exponent 2 over 2. So these are the final two answers. So we have here is either you present this as your final answer or this. Okay, so thank you for watching this video. Don't forget to subscribe, like it, and share it to your friends, and don't forget to hit on the notification bell so that whenever I updated my video, you quickly get the prompt. Thank you. Goodbye.